Topic today is rising of groundwater levels. It is required for rejuvenation of rivers. That's what I put it. So I am formerly at JNT University, now at as adjunct faculty at, after retirement, Professor Jaishankar, Telangana State Agriculture University. So I will start my presentation. So this is, you can see the global level. Groundwater supplies almost 1/2 of all drinking water in the world. Almost 50% what we drink is from groundwater resources. And then groundwater supplies around 43% of the global, consumptive use. That means when you are doing agriculture, most of it goes in the consumptive use water. Is uh, 2/3 of the world groundwater is abstracted in Asia. Of course, India takes the lion's share. I will come to later. So if you look at still some salient features of groundwater is uh, groundwater accounts for approximately 99% of all liquid fresh water of the earth. This is according to World Water Development Report 2022. So if it is a liquid fresh water, because most of the surface water is on the polar ice caps, so that's why if you take liquid fresh water on the planet, excluding that solid one, then it is almost 99%. So that is the state of the groundwater. Africa accounts for about 17% of the global population, which is around 1.4 billion. In fact, even India alone itself now got 1.4 billion. Its groundwater withdrawal is comparatively low. Africa, accounting for slightly less than 5%. So, whereas in the case of India, it is almost 25%. So, to feed their population. In Mexico City, groundwater constitutes 95% of all the water use. So, that is a very heavy use in the Mexico City itself. Okay, then 99% of drinking water of Denmark comes from groundwater. So these are some of the salient features of the groundwater that we can see across the globe. Then 67% of all groundwater used for irrigation. This is another dimension. World's aggregated groundwater abstraction. Of course, if you see 1,000 cubic kilometers, as already I told, Asia is the 1/3 use, whereas India is itself is 1/4. And then 22% of all groundwater is used for domestic purpose. That means when you compare to agriculture, really domestic purpose is less worldwide. Only 11% is used for the industry. So this is another dimension of looking at the groundwater. And then you can, if you look at this, the abstraction, less than 2% this area development, more dark red. These are the areas, particularly this Central Asia, not Central Asia, India, and then the Arab land. The mostly here is desert areas. These are areas where lot of abstraction as per 2010 as percentage of annual recharge. So more than 100% is used in these areas. Okay, that means we are utilizing the groundwater. So now when you come to at a global level, you can see this is a very interesting graph produced by World Water Development Report. Of course, earlier it was prepared by Van der Gun in 2013. You can see some of the developed countries, like you can say USA, this graph, they have already reached a stabilizing groundwater even 2000 itself. Some of these countries like China to some extent, and then even the France and so on. Whereas this Indian scenario, if you look at, this is the graph, and you can see now in even India also it is appears to be stabilizing. So this is the thing. So that means around maybe overall total groundwater withdrawal is around 1,000 cubic kilometers. At some places it is overutilized. At some places it is not. That is the story. And level of groundwater extraction lowest in 18 years finds study within the India. Recently, I have brought this thing. Groundwater extraction in the last 18 years, if you take India, in India, and this is from Central Groundwater Board, normally we used to pump around 250 cubic kilometers, whereas in 2022, a little bit less. So this is the 18 years lowest in 2022, like that this report says. Anyway, these are the some of the estimated total groundwater withdrawal to the percentage that is used for this blue color gives you estimated total groundwater withdrawal. That is roughly around 251 in the case of India, and 112, and then USA 112. That means China and India, China and USA put together, we are using more groundwater. Out of which percentage of total groundwater withdrawn for irrigation, how much? This is one which is 89%. In India, it is used for most of it used for agriculture production. That means irrigation. China, it is 54%. Even USA also 71% of it used for irrigation. Pakistan 94%. Iran, so Southeast Asia and Asian countries, some of them, Bangladesh, and then even Mexico, they are using a lot more for irrigation. Mostly it is used for irrigation. This is the thing. That is the scenario. So in my place where I am residing at Andhra Pradesh, of course, Telangana, all these put together, you can see the surface water. You can see the surface water utilization is almost stagnant for the last few decades, whereas groundwater utilization is increasing. And so this is how the groundwater at some places overutilized, at some places it is now though not underutilized but not overutilized. And this is how groundwater table decline over the world. One of the most disturbing factors, the Indo-Gangetic plain is one of the most declining groundwater, more than 8 centimeters. It is projected compared to many other places, groundwater decline. This was confirmed by the studies recently by gravity studies by NGRI, Tiwari et al. So this is one of the situation. So one of the densest population living in this Indo-Gangetic plain. Let us see. Now I am coming to my own study area where I am residing at Hyderabad, and I have a basin like Musi Basin. In fact, this is the Musi. Both these Musi its tributary, the entire Musi Basin is this beyond Hyderabad, rural areas, and this is urban area. These are the two reservoirs which is ahead of on these two rivers. If the Hyderabad is here, two reservoirs once upon a time they used to supply surface water for drinking purposes for Hyderabad. Let us look at those two reservoirs waters and how the groundwater and then surface water and groundwater over the years, how it is interacting. For example, inflows received, we have calculated inflows received at Usman Sagar reservoir. That means a reservoir here. This is the reservoir. In a total map, this is the here. So another reservoir is this one. This is Usman Sagar. This is Himayat Sagar. You can see here Usman Sagar catchment and then Himayat Sagar catchment. Now, since these two reservoirs are nearby the distance, you can see total inflows received is gradually decreasing. This is the data up to 2009. Even up to 2015 also same. Some 2018 onwards, since the flows were not so big, the extra water coming from other sources, the reservoir, they have stopped using that, not that much. So this is the decreasing inflows to the reservoir. Same is the case, of course, with both the reservoirs. I have not shown the other because the same is the case. Now, if you look at observe the groundwater table in one of these observation wells, okay, these are the trend of groundwater levels which are falling. One is post-monsoon, another one is a pre-monsoon, whereas the rainfall is almost the same, whereas the groundwater levels are falling down. Okay, this is one of the scenarios we found in these catchments of these reservoirs. Groundwater levels are continuously falling down. So then we have searched for the reasons. What is the reasons? And also we found out the very interesting graph. Groundwater levels rise, and here pre-monsoon groundwater level. The deeper this pre-monsoon groundwater, the later when the monsoon comes, the more rise is observed. That means if you are using more and more groundwater in the catchment, more and more water is getting recharged. Why this kind of scenario is situated there in the catchments? Since these catchments are very nearer to the city of Hyderabad. See, Hyderabad city is just downstream of these two catchments. So a lot of agricultural produce is there, like fruits, vegetables, many things. So they are pumping huge ground, the large scale pumping is occurring here, and then they are lowering the groundwater table. Whatever the rainfall that is occurring in these catchments, that is simply getting recharged. So that is the meaning of this graph which we are getting here. The more the groundwater levels rise, more when there is a deeper water table. So that is how we have established this relation. And this is the relation between pre-monsoon groundwater levels and increase in groundwater levels. So pre-monsoon groundwater levels and increase in groundwater levels. And this is the relation between rainfall and increase in groundwater levels. So if you observe these two graphs, it is the pre-monsoon groundwater level which is influencing the rise. That means the more correlation is with the pre-monsoon groundwater level rather than the rainfall itself. That's some of these physical factors. And for the entire Musi also, we have done such exercise. You can see these are some of the hotspots. Actually, these are reverse. In fact, the cool color indicates the deeper groundwater levels. The hot colors in the different. Actually, we have calculated difference is the pre-monsoon level and post-monsoon level difference. So wherever this pre-monsoon groundwater level is there the difference is more between pre-monsoon and post-monsoon. So that is how we have observed. So this is the story, even in a very this is a hard rock area and where you are pumping a lot of water. But that story is not ending there. Even when you observe in the bigger catchments like Krishna, the Musi basin, what you have just now seen, is a sub-basin of Krishna. So there are this is a very big, large basin. Krishna is the southern river, and you can see because of this, you can see here cumulative life stories goes on increasing. That means we are intervening the free flow of water by building number of barrages and then anakettes and then big reservoirs like Nagar and Sagar and so on. As it is increasing, this runoff coefficient, you can see it is getting decreased. That means lesser and lesser water is being released into the main river, and a lot of water is being used in the upstream. Downstream is we are released. That means this almost a Krishna basin is a closed basin. Both groundwater wise as well as surface water wise, upstream utilization has been increased. This is not only hold good in Krishna but even in Ganga. This is the mean monthly graph for Ganga River, of course, the old one, even in those days, by 1980s itself, 1850s, 1900s, and 1980s itself, even Ganga also, the surface water decrease has been observed. This is a prominent in almost all river basins, particularly in monsoonal climate. And particularly for Ganga basin, you can see non-monsoon and monsoon. This is the slope of the trend. Monsoon water is getting low, whereas non-monsoon water is getting higher. There is a climate change. The relation is there is a climate change, and where annually at the upper reaches like Rishikesh and other things, Ganga has having a lesser flow, only downward, that is Patna and other places you are getting these are some of the stories. Surface water and groundwater are connected. So then this is a recent graph worked out by one of our colleague. Static water level anomalies, you can see decrease in Ganges river discharge, Mukherjee and Bhanja and others. So groundwater levels decrease is also seen in such a big basin like Ganga. And same is base flow also is getting reduced. Now, why these rivers are getting lesser base flows and even drying up sometimes, particularly peninsular rivers, not Ganga. So there is, you can see the groundwater can contribute to the river. For example, you can see losing stream with the shallow water table. For example, you can see when this is the height of the stream water, whereas water table is below the level of the stream water, then it can contribute to the groundwater. That means it's used for recharge. The stream is recharging the groundwater. But whereas in the other case, gaining stream means when the stream water is lower, that is non-monsoon season, then this groundwater table will lose water to the river. This is how once upon a time rivers are perennial. And in Ganga, just now we have seen the graph, we are getting decreasing this water in the non-monsoon season. That means contribution of the groundwater is so less. So now in the peninsular rivers, this stream level, no connection. Only stream is contributing. There is no question of getting the water from the ground. So that is why the are not getting water. That is, we need to increase this water level, groundwater level, so that streams get a stable water. That is our concept. So Indian deltas are sinking. This is another concept. Like as we have seen the river like Krishna, river like Ganga, they are drawing lesser and lesser surface water and lesser sediments at the end of the mouth when they are joining the sea. So deltas are not getting that silt and sand. Usually once upon time they used to get. That's why when the sea level rises because of the climate change, these deltas getting are inundated. So this is also another climate change. And of course, we have tried, particularly in Deccan, India. That means it is a rain shadow region with some kind of, the kind of artificial, people popularly known as artificial. It's not artificial, weather modification technologies. So this weather modification technologies we have used, and there is some success, 20% of increase of rainfall, so that in a critical time we can get water to the crops and all those things, managing the crops. So and then at the farm level itself, ponding in critical times, we can give the irrigations to the crops which are not so well in the lean period. That means when there is a gap, 15 days, 20 days gap in the monsoon, then we can give. So these are some of the techniques we can use. So, but once when you have started all these techniques, when we start utilizing more surface water, which is rainwater, then in Telangana, one of the most states which have taken up the recharging of water by desilting the entire tank, slowly groundwater level has increased. in the last 15 years, I mean 10 years, something like that. The data shows from September 12th to almost 22nd of 1 year. It shows that the slowly increasing. I think it is September 12, November, January. This is the Musi, which is flowing in, at least in the monsoon for the last few years. This is the one story I want to. So they have used a lot of recharging techniques like desilting of tanks, irrigation tanks, and then filling them with the rainwater, and using of this sprinkler and drip irrigation and so on. So this is what the concentration that matters. In the urban areas, heavy pumping is resorted to due to more concentration of people in a limited area. So in spite of normal rainfall, many times in urban areas, there is no groundwater in summer. For example, in this year 2023, most of the bore wells in Hyderabad gone dry in spite of recharging. This is another. That means more and more concentration we put in. That is more than climate change. It is anthropogenic reasons we are making this groundwater unavailable like that. Okay, this is another way of looking at. So what is the way forward? The adapting the water and soil conservation technologies by first utilizing the soil water optimally. So we must utilize soil water properly. Then only we can go for surface water irrigation through smaller scale to larger scale. Whenever needed, the larger scale structures also needed. But try to utilize the surface water initially, either by small ponds or bigger reservoirs. Doesn't matter, based on the climate there. The groundwater irrigation option should be exercised only as last resort. So that is the thing we have to follow. Then we can save groundwater. Then various groundwater modeling studies in the Deccan Plateau, where I have shown these graphs, suggest that groundwater utilization for the irrigation must be reduced to half of use. Adoption of sprinkler and drip irrigation, micro irrigation techniques, whatever the manner micro irrigation you adopt, you must utilize this surface water properly, because we have seen in many cases 40% of the applied water irrigation does not reach the plants according to World Bank. Okay, so that is the method, I mean the way forward. Water intensive methods to be modified. No need of this is another thing. Even in ICRISAT, they said even sprinkler method you can irrigate for the rice. Upland rice cultivation is gaining popularity again. Earlier we not, but with the less availability of water, the broadcasting the seeds on the with a moderate moisture, then they will grow and we can irrigate now and then. That is called upland rice cultivation, because rice is taking a lot of water. Sprinkle irrigation can also be used for rice cultivation. According to World Bank stats, I was referring to this. 40% of applied water never reaches the plants. This is the problem. We have to save a lot of water from the irrigation, because we are using a lot of groundwater in the irrigation. That is the thing. There we save, and then we can increase the water table, and then rivers also can be get their lowest in the lowest web. When there is a dry season, then this groundwater will contribute to the rivers. Okay, then capturing sky water with the weather modification also is a one option. It's not a bad idea, but it can help to mitigate some of these problems. For all these activities, more investments are to be made. This is a social aspect of the economics. For all these activities, more investments are to be made by the farmers in the agricultural farm sector, which can happen only when the farmer's income is double to the present day income, because nowadays agricultural inputs have increased largely, mostly fertilizers, pesticides, and many more labor costs have increased. So in order to implement these sprinkler irrigation, drip irrigation, or in order to take up on a large scale weather modification or on-farm techniques, more money is required. Unless the farm produce are sold out in a better way for the farmer, maybe in the form of support price or some other price, the market should get more money to the farmer. Empowering of farmers cannot happen unless there is a proper market price for their agriculture produce. So one of the poorest enterprises are the farmers today in South Asia and Southeast Asia. So that's why we have to increase their income. This is another thing, the social aspect of it. So organizational strengthening, of course, this is with regard to the subject, creating of national, international groundwater data repository at an international level. Many people are working. Strengthening of the state and central groundwater boards are to be strengthened nowadays. Research institutes are to be strengthened for the groundwater studies and so on. It has to be put on. So this at a institutional level, increasing the capacity building and also. So this is the thing, a photograph I want to show you. In 2015, I was traveling on the roads of the Rome to some place. I thought the water is simply leaking from the tap. In a developed country, how it is leaking? Then I came there. People said it is for drinking. This is water coming out directly from the spring, and they have arranged in such a way you can directly drink. Otherwise, the water will again go for recharge. That means water is under pressure. It can come to the top. So that level, if not, at least the particularly in these monsoonal countries, in a arid and semi-arid regions, water table maintenance is the to develop on. Thank you very much for your patience hearing. Thank you.